Alright, welcome to class. Today we'll be looking at scalars and vectors. And what I will do here is that I am going to be focusing on the physics aspect of scalars and vector. Okay? And then before we do anything in this topic, we have to, first of all, get the learning content. So we have the definition of terms, and then as well as okay. So if what I will do is that I will call this scalars and vectors 1. Okay, so that I can make another video for the second part. We'll take the first content here. We have definition of terms. In the definition of terms, we are to define the terms scalars and vector. So if we are to define the terms scalars and vectors, we have that scalars are quantities, because this has to do with classification of physical quantities. Yes, with this two property. Based on these two property, we have the magnitude and duration. So with the sense of magnitude and duration, we are to classify all the physical quantities into this group. Now we have some quantities that can be completely described with just its magnitude, but other quantities cannot be completely described by just getting the magnitude. All right? So quantities which can be completely described with the sense of magnitude are scalars. If you do not call it scalars, you can also say scalar quantities. All right. So we are saying that these are quantities that have only magnitude, but they do not have any sense of direction. So in the description of such quantities, the magnitude is very, very okay. Right? If you say, for example, point A and B are 2 meters apart. The information you gave to us is the magnitude of the length or extent of space between A and B. There is nothing more. You've not given us the direction of B from A or A from B. So if we are looking at this as length, all right, the magnitude of length is also distance. We use the word distance to describe a length covered by a body that moves. So when movement is involved, we call it what? Distance. All right? So, but if there is no movement, the body is static, we leave it at length. Also, if we are talking about object, if we are talking about object, or if we are dealing with object that is two-dimensional, we are going to have the breadth, meaning that one dimension out of the two dimensions of the object, one will be length, one will be breadth. The length is for the longest side. So if we have three-dimensional object, we also have additional quantity called the height. So all of them have the magnitude length. Okay. So we also have others too, even displacement. Even displacement. But I think when we get there, we'll explain. Even displacement, when we talk about the magnitude, it's still the same. So this object here, these physical quantities here are completely described with just its magnitude. There's no sense of direction. So these are what scalar quantities. Also, when you are telling the time, okay, and the time is, please do not mind my drawing. Okay. Okay, if the time is 12 o'clock, you are not going to say 12 o'clock north or upward. So, any physical quantity that can be completely described by just the magnitude are scalars. So, since someone is not waiting for you to say it is 12 o'clock upward before he or she understands what you are trying to convey, what you are trying to say, so this time will become what is a scalar quantity, not become, is a scalar. Yeah, time is a scalar. So other quantities, we have the mass. If you are asked to give the list of scalar quantity, you have mass, length, time, you have distance. And when I talk about length, all this, all right, aside from this, all this, the height, the breadth, the width, all this one, involve area, and we have volume, and many more, temperature, and so on. So let's go to vector. Vectors. If you do not call it vectors, it is also vector quantities. Now, these classes of quantities does not stop at magnitude in its description. So this class of quantity needs another sense, that is a sense of direction. So if you are to describe this, you can say completely with direction, you can say A is 20 meters left of B. See this? So this someone trying to imagine anything about these 2 points will know, if you just say it as a statement, the person can actually draw it this way. But when you were saying A is the distance between point A and B is what? Is 20 meters. So you can have so many diagram. Yes, for that. Someone can decide to take it this way. It's a point, all right? Point A, point B, all right? 2 meters. It does not matter, all right? You see this? All right? And many more. So, but this one that you have given the direction, the only one that can fit in here is this. So, this one cannot be considered. So we said, so this particular description, you have given distance and you have given direction. This particular description form a quantity called displacement. Yes, the magnitude, which is distance, plus the direction give us displacement. So first example of vector or vector quantities, is displacement. Don't forget this one. Don't forget displacement. And here, I think we have speed and so many of them, right? We have so many of them. You can do the list. We have the speed and so many of them. So yeah, we have displacement. But let me just give you a little tips. At this level, if you want to know other quantities, at this level, at this elementary level of physics, most of the vector quantities, aside from displacement, displacement is the only vector quantity that is not what? That is not a derived quantity. Okay? Okay, yeah. So every other quantities are derived. Let's look at velocity. Velocity is displacement over time. Velocity is displacement over time. And remember that velocity is gotten by combining displacement and time. And also speed was gotten by combining distance and time. So the quantity here is scalar. The quantity here is scalar. The quantity here is a vector. The quantity here is a scalar. Not all the quantity, but most of the quantity you will come across at this stage that are vector quantities depends solely on their what? Combined quantities. So if one of the combined quantities is a vector, the quantity become a vector. But I'm saying not all. So you need to sit down and study some of them. Velocity is a vector. Displacement in direction of this, the displacement is a vector. So when you combine the vector and the scalar, you get what? The vector quantity. You see, scalar and scalar combined give us scalar quantity. So another example of vectors. Another example of vector is velocity. So if you also want to get an example, you can have acceleration. Acceleration is change in velocity over time. Velocity over time is and velocity is, so you have acceleration. So you can also have another one is force equals to mass times acceleration times acceleration. And you have acceleration is what? So we also have the weight equals to mass times acceleration due to gravity. So the force and weight of a body. You also have you have force weight of, you have impulse equals force times time. You have momentum equals mass times velocity. All right. So this is what? So you have an impulse. You have momentum. Please, Okay, what if you decide to say that potential energy is, we have a potential energy equals to, you may decide to say that potential energy is a vector because of acceleration due to gravity. Please, it is not. That's why I say it's not all the quantities, but some quantities, so many of the quantities you come across are what they are, you can tell from the combined quantities, but not all of them. Okay, are you going to say that because of that statement, that this is also a vector? No, anything energy is a scalar. All right, anything energy is a scalar. So I think we are done with the first. Okay, we're done with that. Okay, under there we also have our vector representation of vector. So let's see, that's one representation of vectors. So we represent vectors with an arrowhead, a straight line having an arrowhead. Okay, let's assume this is a, now this, the length of the vector, the length of this line represent the magnitude. Okay, while this arrow represent the direction. So can represent it with the sense. Also, it can also be represented with, see now, with the letter. You can represent it with a letter. Put this to show the sense of that it is what, a vector quantity that we are dealing with. We are dealing with vector quantities. So vectors are represented in magnitude and direction by what, a straight line with an what, arrow head, a straight line with an arrow head. All right, so we'll go to geometrical classification of vectors. Geometrical classification of vector. We have three classification. Okay, we have parallel vectors. We have perpendicular vectors. We have angular vectors. Please, if you look at types of vectors, there are so many types of vectors. I'm saying that I am only going to teach this based on what you need in physics, JAM, and YX. So I'm not here to teach everything about vector. So I'm just focusing on JAM and YX physics, what is needed there. So you have parallel vectors. These are vectors. When we look at it geometrically, we can say if there are two vectors, okay, the angle between them is either 0 degrees Celsius or 0 degree or 180 degree, and then this other one 90 degree, and this one will always be between 0 degree if it is x. Let me use theta. Right, so these are parallel vectors. So this one, these two vectors, if two vectors, for example, maybe P and Q, for example, parallel to each other, and they are parallel vectors, and in this sense they are parallel and in the same direction, parallel in have the same what? Direction. And in the same direction. So the vectors are in the same direction. If they are in the same direction, what we do is that it's very easy for us to combine vectors that are parallel like this. We just combine by adding, if we select the combining vectors be R, so we have that the combination of such vectors would be with just simple addition. All right, we can just add the vectors together, this plus this. So that is when they are what? Parallel and they are in the same direction. If they are parallel and are in the same direction, we just add them together. So let's look at this other one. And this one, you have that the angle between them is a 0 degree. So what if they are still parallel but in opposite direction? For example, you have P and Q. They are parallel and are in the opposite direction. And are in opposite direction. So what happened here is, if we select the result of combining the two vectors P R, we're going to have P minus R. All right, and it is in the direction of the vector with the highest magnitude. All right, so the vector with the highest magnitude minus the vector with the what? The least magnitude. So that is how to find the sum of what? This type of vector. So let's go to perpendicular vectors. Now, if vectors are perpendicular to each other, we can say that P and Q perpendicular, P being perpendicular to Q. That is to say that there are, look at it here. There are 90 degrees. The angle between them, all right, is 90 degrees. So if you want to find the sum, you see that you have to, all right, this vector, they're perpendicular to each other. The line joining the starting of the first vector to the what? The starting of the first vector to the end. All right, this is the terminus. All right, so the line joining the starting to the terminus of the last vector is the sum of the two vectors. All right, so okay, this is what it is for vectors that are perpendicular. I think we should see how we can find the sum of these vectors. Okay, so whenever you have two vectors that are perpendicular to each other and you are asked to find the sum of the two vectors, for example, we have a P and Q. So the sum, we will present it with how, and then we can now introduce maybe a angle between the horizontal vector and the what? The sum of the two vectors. So if you look at this very well, you see that this has given us a right angle triangle. Since we have a right angle triangle, what we do now is we can use Pythagoras' theorem, that is Pythagoras' theorem, to get the sum of the two vectors. So according to the Pythagoras theorem, you have that the sum of what? A square in the longest side of any right angle triangle, you is the sum of square of the other two sides. So we say that if you take square root of both sides, you will have this to be what? If you take square root of both sides, you will have the sum of the vectors to equals to the sum of squares of the other two vectors. Right? The square root of the sum of squares of the other two what? Vectors. And also we can also find the angle, we can also get the angle between, find the angle between the sum and the horizontal. You can have this one as the angle between the sum of the vectors and the vertical. But let's consider this one. You have this to be tangent tan alpha equals to the opposite over the what? The adjacent. So you are going to have the angle to be equals to tan inverse P over Q. So that is how we'll find the sum, all right, of two vectors that are perpendicular to each other, as well as the angle between the horizontal and the what? And the sum. All right. So the next we have to consider is the angular vector. But before we consider the angular vector, I would love to bring this, is. I would love to bring this to you. So you have resultant vectors. You have me saying combine, 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 or the sum of the vectors. All right. Actually, the sum of the vectors is what we call resultant vectors. The result you get by adding two or combining two or more vectors together. Right? So if you are combining two or more vectors together, the result you always get is called resultant vector. So we said that resultant vectors, this is a single So we said that a single vector which will have the same effect in magnitude and direction as the two or more vectors acting together is known as resultant vector. It's known as resultant vector. So this is a single vector which will have the same effect in magnitude and direction as maybe whatever numbers of vectors are acting together. If you sum them together and get a single vector, that single vector is a resultant vector. It will have the same effect as those vectors all combined acting together. So remember this word vector here represent all vectors quantity. So if someone asks you to find, well, so if someone asks you to define resultant force, the only thing you do is where you have vector, you replace it with what? Force. If somebody says you should define resultant velocity, it's still the same thing, acceleration, whatever it is. Okay. So this result is always the what? This result by combining the two vectors is the resultant vector. We call it resultant vectors. All right, let's see. The next one is this. We have known how to handle parallel vectors and perpendicular vectors. So this time around, we'll look at angular vectors. Angular vectors. Now, before we can see how we can handle these angular vectors, we now have to introduce two laws: triangular and parallelogram law of vectors. For triangular, you know that triangle is a three-sided shape. So if we are having two vectors, we can represent these two vectors in what? In magnitude and direction by two sides of a triangle. So whenever we do that, the third side becomes what? The resultant vector. The third side becomes the resultant vector. All right, let me copy down the meaning for you. Let me pause the video and write down the meaning for you. All right, so triangle law states that if two vectors are represented in magnitude and direction by two sides of a triangle, the third side is the resultant of the two vectors in magnitude and direction. In magnitude and direction, the third side is the resultant. Now, if, for example, let's consider two vectors P and Q, for example, you have P being a horizontal vector, and then Q being, and then the angle between them, this time around, the angle between them is not 90, is not 0, and is not 180. So when the angle is not 0, is not 180, and is not what? Is not 90. I mean, it means that the vectors are what? Are a particular angle inclined to each other. So we can represent the vectors, right, by two sides of a triangle. So if you have this, a triangle like this, so we represent the vectors what? By two sides. So the third side here, the third side is our resultant vector. The third side is our resultant. So if the third side is our resultant vector, we will have this. Okay, let's see. This is not a right angle triangle. Remember, this is not a right angle triangle. So for us to find the resultant, we'll now introduce a cosine rule. All right, let's see. So we have, since the angle here is known, this is 180 minus theta. So you're going to have the cosine rule. That would be r square equals to p square plus q square plus 2, minus 2p times q cos 180 minus theta. Now, since this has entered the, let's see, the second quadrant, then you are using this principle. In the second quadrant, the cosine is negative. So, and also cos 180 minus theta is equals to minus cos theta. All right? Yeah, equals to minus cos theta. So what we are going to have here is r square equals to p square plus q square plus 2pq, then cos theta. This is how you find the what? The resultant. of the two vectors. All right. So for you to find the, maybe for you to find the angle between one of the vector and the resultant, is that you are going to use sine rule. Is that you use sine rule, or you devise a mean to make this a right angle triangle. Let's say if we make this a right angle triangle, what are we going to have? So let's use sine rule first. In this case, if, okay, we are not considering this yet, so let's see. What we're going to do now is, if you are taking the sine of this angle, divide by the what? The ratio of the sine of any angle and the opposite side remains what? Constant, right? So this other one, sine 180 minus, which is still theta, over the resultant. So we can now say that our alpha equals to, all right, our alpha equals to, you have q sine theta over r, or sine inverse. Do I get that? A cross multiply, let's see. You have to cross multiply, you're going to have r sine alpha, and then equals to q sine theta. So you divide through by r, so you have q sine theta over r, then you take sine inverse of both sides, so you get this. All right, so this is for finding the angle between maybe the horizontal and anyone there. Sorry, the horizontal and the resultant, I mean. So let's see how we can also, there's another formula for handling this. We can derive another formula for that. If you look at this, this is q, and that is if this place is x, for example, and this place is y, and you have to find this place, let's see, x is opposite, so we have sine theta equals to x over q. So in this case, x will be equals to q sine theta using SOHCAHTOA. And you know that that only works on right angle triangle. So this will be q sine theta. So if that place is q sine theta, this one will be y. This is adjacent. We have cos theta equals to y over q. So you have y equals to q cos theta. So here you are going to have q cos theta. So if you have q cos theta, you can get another formula for this. This is horizontal, right? This P has been given to you as horizontal. This formula only works when you know that a particular vector is horizontal, right? This particular one, this one can work with anyone, whether any of the vector, even if you don't have any vector that is horizontal, you use this one. But whenever it's stated in that question that one of the vector is horizontal, you can use this. Now you are now looking at this. So if we are erasing this, you'll notice that you have what? You have a right angle triangle. So you have the tangent tan alpha equals to opposite, which is q sine theta. Over here, the whole of this length is P plus Q cos theta plus P plus Q cos theta. Let me draw my line back. So you take sine tan inverse of both sides, you have this. All right. This is when you know the vector, the one that is what? Horizontal. Remember where you find the one that is horizontal? The vertical or any one that is not horizontal, sine theta over the horizontal vector plus the other one, cos theta. All right. So these two formulas can solve. Remember this particular one, as I said, this particular one is only used when you are not sure whether any of the vector is horizontal. But if in the question it is clear, it is stated that one of the vector is what is horizontal, you have to use this, and this is always the horizontal vector. The other one is either the vertical, the slanted, whatever it is, but you have to know which one is horizontal. Once you know the vector that is horizontal, you use this formula to solve, or you use this one to solve if you are not sure. And remember, this one works for all, for you to find the resultant of the two vectors. So let's also consider this particular one too, the parallelogram law. Parallelogram law. If you are looking at parallelogram law, let's say you have, okay, let me state the law first. So you have parallelogram law. I would love to pause the video then write down the law for you. Okay. All right. As I said, the parallelogram laws of vectors state that if two vectors are represented in magnitude and direction by the adjacent side of a parallelogram, the diagonal of the parallelogram drawn from the point of intersection of the two vectors represent the resultant vector in magnitude and direction. As we have done with the triangle law, something is applicable to the parallelogram law. So let's consider two vectors. We're having two vectors P and Q, and you are asked to represent it in adjacent side of a parallelogram. So you have this. For example, this is a parallelogram, and then this is vector P and this vector Q. All right. Then the angle between them is theta. So always remember that this triangle law and parallelogram law is used when the two vectors are not parallel and they are not also perpendicular to each other. So if you draw a straight line from the point of intersection to the opposite corner of the parallelogram, that straight line represents the word, the resultant of the two vectors. So if you are to find the resultant or the magnitude of the resultant, you still use the cosine rule. So you have r squared equals to p squared plus q squared plus 2pq cos theta. So, all right, the only difference between the triangle law and the parallelogram law is just the diagram. But when it comes to the approach or the formula used to calculate the resultant vector, it's the same formula. We use the same formula as well as the same formula for calculating the angle of inclination of the resultant vector. That is the angle of inclination of the resultant vector from any of the vector. Maybe if we are considering a horizontal vector P, you are going to use the cosine rule, or you use the tangent. All right. So this is all about parallelogram law. So let's consider Let's have a question first, and then look at this question. I have one question. All right, let's look at this particular question. It says, suppose a car traveled 24 kilometers northward and from a particular point and 20 kilometers eastward. What is the displacement? And remember, the displacement here is a vector. So we are given this type of question. What you do is you interpret the question using a diagram. All right. So you have your solution, and then let's see. From a particular point, let's call it point A, the car traveled to the north. Let's say the north is point B, and that is 24 kilometers. From a particular point A, the car traveled to another point B. All right, northward, and then traveled to the east 20 kilometers. East 20 kilometers, and then we can call this point point C. They are asking, what is the displacement? All right. So what you notice here is that this particular place is 90 degrees. So because of that, these two vectors are perpendicular. And the direction is travel from here then to this point. So for us to get the resultant, from the starting point of the first vector to the terminus of the last vector, we get the what? The resultant. So this has formed a right angle triangle. So we can solve this using Pythagoras theorem. Pythagoras theorem. So we have r squared equals to 20 squared plus 24 squared. All right. So this is 400 plus. Then let me show you without your calculator you can work this. 4 squared is 16. You write down 6 carry 1. Then you multiply 2 by 4 by 2, and that gives you 2 by 4 is 8, by 2 is another 16, plus the one you carry, that is 17. You have 7, yeah? You keep 1. These other 2 square give you 4, and 4 plus this is 5. So you have 5, 7, 6 as 24 square. So when you add it up together, you have 9, 9, 7, 6. So r square equals to 976, and you have to take square root of both sides. So take square root of 976. All right. So when you take square root of 976, you have this would be the closest is 31. All right, 31 point. Please, you can use your calculator. Use your calculator. You have 31.24. All right, with the help of calculator. 0.24. Now, notice that the vector given to you is in kilometers, so this is kilometer. All right, so you also need to find the angle of inclination either from the horizontal or the vertical. So in this case, we'll consider the starting point, which is the vertical. So you have tan alpha will be equals to the opposite, which is 20, over the adjacent, which is 24. And what will you have? You have, okay, what can cancel here? 2, 4 cancel here, 5, and cancel here 6. So you have 5 over 6. All right. So you can press your calculator. If you're using scientific calculator, you press shift, then you press tan, then put this figure in there to get the angle of inclination. So what you will have is 56, all right, 56.44 if you're using your calculator. So now the displacement. Now if you are to write down the final answer, say therefore the displacement is 31.24 kilometer. You will not stop there because this particular quantity you are dealing with is a vector quantity. You cannot just skip. It said displacement 31.24 kilometer. That is just the magnitude. Okay, so you have to also look at the direction. If you look at the direction, it is from north to east in north 56.44 degree to the east. So that is the displacement because this particular quantity you are dealing with needs magnitude as well as direction. You cannot describe this quantity with just the magnitude. You must as well identify or find the direction. All right. All right. Let us also consider this question. You have a boat sails 200 kilometer 30 degrees east of north and then 150 kilometers 60 degrees south of east. What is the resultant displacement? What we have to do is we have to get this in a diagram first. It will really help us to see how we can find the resultant displacement. So if we are taking this point A to be the starting point, this is the north, this is the east. It's a 30 degree east of north. That is to say, from east to north, you have 30 degree. Yeah. Right. And this was the displacement is 200 kilometer. And then reach another point, and that point is point B, let me call it. And then the boy now move south to east, that is south. -60 degree. All right. South of east. All right. So, and that is about 150 kilometer as displacement. Now, if we have 30 degree here, this side here will be 60 degree, and then alternate angle are equal. So if here is 60 degree, means that this also will be 60 degree, meaning that the whole of this place will give us 120 degree. And then to another point, all right, so to this point, you have here the alternate angle If here is 60, here will be 30. So we can have diagram like this. Okay. So this is just a rough sketch. So let's try to bring this out. So if you bring it out, you will have diagram in this form. Here will be 120 degree. There will be your 30 degree. And this is A, this is B, and this is C. Here is 200 kilometer. Here is 150 kilometer. So remember, the resultant vector will be this point, the third side. So if this particular place is 120 and here is 30, we think that the angle between this would be, if you are using sum of angle in the triangle, you have that the sum of angle in the triangle is 180. So if you add it 120 plus 30, that is 150. So what is left now to make it 180 is 30 degree. So you have that r square will be equals to 200 square for square, all right, plus okay, cos 120. And now since 120 is in the second quadrant and each time we have a cosine of angles in the second quadrant, such becomes negative. So you're going to have here 40,000 plus minus, if you multiply this together, you will have 15 times 2, and that you have 30, and 30,000 times 2, you have 60,000. So you have 60,000 cos 60, because whenever we have cosine of angle in the second quadrant, it will always be negative cosine of 180 minus the angle, so you have negative cos 60. All right, that's how we got this. Yeah, on the negative side there. So, and cos 60, all right, so cos 60 is 0.5, that is half. Okay, let's check. So what we have to do now is, okay, cos 30 is 0.5, so you have add this up. This is 40,000 and this is 22,000. So 40 plus 22, that is 62,500, and 62,500 minus this is 60,000. 60,000 times 0.5, that will give you 30,000. And then if you subtract 62,000 minus 30,000, you're going to have 32,500, right? So you take square root of both sides. Take square root of both sides. So you have a square root of 32,500. Let me use my calculator. Square root of 32,500, you have 108.28 kilometer. All right. So if you look at the diagram very well, if you see the angle between both the vector and the resultant and these are 200 kilometer, right? It's already 30 here, and the same thing is already 30 here. So you don't need to stress yourself there. So the displacement here, the resultant displacement is this in any of this direction.